All right, welcome to day 2 of our Regents review. You can be writing day 2 problems in your planner, and if you could also be taking out last night's homework. Now, a reminder that your homework should be done on a separate sheet of paper, and even if there's multiple choice questions, you should be showing work. If it's a question that you stored and you put in the calculator, make sure you write that you stored it with your answer. And the reason I want them all on a separate sheet of paper is so they're all in one spot, so you're not having to flip through the book to find each of the questions as we go through. Now, the one exception to that is if there's any that you're putting on like a grid or a graph that are in the booklet, you can put those ones in the booklet so you don't have to find separate graph paper. All right, so our first one was number 2. There's 2 ways we could do this. First, the mathematical way, write it twice and FOIL it out. Remember, you don't want anything more than I to the first, so that I squared there with the 4i you can put in the calculator, and that gives you -4. And then just pick which choice matches, which was choice 3. Now, remember, one of our key words is equivalent for a store. So looking over on the side whiteboard, we have equivalent, simplifier, simplest form. If you see those words at all, we can store a random number for the variables and see which choice matches the original. Now, the key thing to keep in mind here is the only variable here is k. So you could store a random number for k using I as your imaginary I that's with the pi, type in the original and type in your choices and just see which one's the same. So 2 different ways to do this. I showed the mathematical way, get 1 square root on each side, square each side. You'll have to square again and then solve. We'll scroll down to see that. So you eventually get 2 and 22, but then you have to check them anyway and you reject the 22. So, if you ever have a square root equation on a multiple choice, it doesn't really make sense to solve it out mathematically. It makes the most sense just to store the answers. So again, let's look over on the side whiteboard. In that second group, if we have solution set or find the values of x, t, theta, or any other variable, we just store the possible answers and see which ones work in the original problem. So I would suggest of our choices to start by storing 2, because it was in 2 spots. So if you store 2, type in the original equation, you would get a true. So that would tell us that it's got to be either choice 2 or 4. And then store 22 and try it out. You would get false. So that tells us it's got to be choice 2. We got another solution set 1. If you did this the mathematical way, you would add the 1 over. You would square both sides. Again, when you square a binomial, remember that means you got to write it twice and FOIL it out. Get everything on one side. You didn't have a constant, so you could pull an x out. So x times x plus 1. Set them equal to 0. You get 0 and -1. And then store those answers to check them, and they both checked out. But because you're going to have to check anyway, like on a radical equation on a multiple choice, just store the answers right away. And probably 0 would maybe be the first one that you would check because it's in so many spots. 0 checked out. So then you could get rid of choice 1. Then maybe it doesn't really matter then from there. Either try 1 or -1, and you would eventually get that the -1 works as well, so that would give us choice 3. And in 25, we had to see where the error was. Well, she said that I squared was a positive 1, and it should be a -1. And then you just had to continue it from there. So we would really have -1 times -4 to give us +4, combine it with the 6 to give us 10 plus 10i. So you get 1 point for identifying the error, and then 1 for correctly finishing it. All right, so we're going to start with rational expressions today. So in our booklets, if we could flip to August 2017, so A's mean August, JA's mean January, and JU means June, and they're in chronological order. There's always a January test, then a June test, then an August test for that year. So again, we'll give you about 30 seconds. See if you can flip to August 2017, And also make sure that you have your calculators out. If you've borrowed a calculator, make sure you sign your name out and that you return it at the end of the period. So this is actually a rational equation because we have an equal sign. When you have a rational equation, we want to get a common denominator and then drop the denominator. We saw this in one of our review mini units. So every denominator needs to have a p plus 3 and a p minus 5. So this one needs a p plus 3 multiplied top and bottom. The middle one needs a p minus 5 multiplied top and bottom. And the last one also needs a p minus 5 multiplied top and bottom. All right, so this will give us our common denominator, so we can drop the denominator. Let's rewrite what's left. We've got 3p times p plus 3 minus 2 times p minus 5 equals p times p minus 5. And now we're just going to solve this equation. The most common error in this step is people forget to distribute the negative with the 2. Okay, you need to recognize that's a negative 2 that's being distributed, not just 2. So we'll distribute the 3p first, and we'll get 3p squared plus 9p. We'll distribute the negative 2, we'll get minus 2p plus 10. And distribute the p, we get p squared minus 5p. Combining like terms on the left, we get 3p squared plus 7p plus 10 equals p squared minus 5p. When you have a mixture of p's and p squareds, or to the firsts and squareds, we want to get everything on one side so it's equal to 0. So we'll subtract the p squared over because we want to keep a positive squared term. And we'll also add the 5p over, giving us 2p squared plus 12p plus 10 equals 0. We can go ahead and divide everything by 2 to make our life easier. If we couldn't divide everything by something, we'd have to do the a times c method. And now the riddle we should be asking ourselves is what multiplies to 5 and adds to 6. So see if you can think to yourself, what are two numbers that will multiply to 5 but add to 6? And hopefully we thought plus 5 and plus 1. Now remember, if you can't think of that, take the number you want to multiply to, so 5 in this case. Go to a graphs page and do 5 divided by x. Do a control T to go to the table, and that will show you all the pairs of things that will multiply to 5. You've just got to find the 2 that will add to 6. So we'll set those each individually equal to 0. So we'll get p equals negative 5 and p equals negative 1. Fractional equations, radical equations, log equations are the three you always have to check. So we want to store these each for p and then go back to the original and type it in. If it comes back true, then we keep the answer. If it comes back as anything else, so false, non-real, undefined, any of those, we would reject our answer. So we are going to pause the video for 2 minutes to allow you to check those answers of negative 5 and negative 1 in the original equation. So on your calculator, remember you do the number and then the store and then the variable. Store is control and then variable right above the 9. Now, just to make sure we're okay with this, once you have already done 1, notice I've now stored the -1 for p. Don't retype the fraction in. Just go up and highlight it, hit enter to bring it down, and hit enter again, and that will check it for us. So both the -1 and the -5 checked out. So both those answers are keepers. All right, next we are going to go to June 2018. We're going to look at question 3. I'll give you 30 seconds to flip there. Again, June 2018. And we want number 3. Okay, we want to find all the values of x for which the expression is defined in simplest form, and it's equivalent to. So there should be a word that jumps out there that tells us how we should approach this problem. We want to see that word equivalent. Look over on the side whiteboard, okay, right next to the I ate some pie and it was delicious sign. Equivalent, simplify, or simplest form. We want to store random numbers for the variables and see which choice matches the original problem. So when you pick a number to store something that you don't really see in the problem. So we probably want to avoid 3's, and I would say always store something bigger than 2. So let's store 4. So let's everyone store 4 for x. You're going to type in the original, see what value you get. 1 and 2, you'll be able to know if it's the answer or not if you get those numbers. If it's not those 2 numbers, then also store each of these and see if you get those back. Okay, so we are going to pause the video for about 2 minutes. Store 4 for x, type in the original, type in your choices, see which one matches. All right, so we should have stored 4 for x. Couple important points I want to make off of this. So we stored 4 for x, and you should have got 7/4. So that was our original. Well, that automatically told us that 1 and 2 did not work, because those are not 7/4. So now when you type in the third one, notice we got 7/4. So the first important point I want to make is, just because you get one to work, you should not stop typing in the other choices. Okay, sometimes it's asking for simplest form, like this one, so we could have multiple ones that work, and you have to pick which one is simplified. The other point I want to make is when you try to type in this last one, when you hit enter, you get invalid implied multiply. So what that means is the calculator does not like it when you have variables next to something that's not a number. So we want this to be x times that parenthesis. The calculator forces us to actually put the dot in for the times. So if you have x next to another variable or a parenthesis, okay, those are the most common things you see, you have to physically put the times in so that it will give you the 7/4 back. So notice now we got 2 things that are the same. So of those 2, we would just have to pick which one is more simplified because they wanted simplest form. Well, 4's got x squareds in it, so 3 would be the more simplified form. All right, now the mathematical way. To do this mathematically, we would want to factor both parts. So I'm going to write the numerator down. We have 4 terms, so we'd want to do factor by grouping. We could take an x squared, leaving us with x plus 2. Rewrite your x plus 2, and you could take out a -9. That means we now have x squared minus 9 and x plus 2. But the x squared minus 9 can factor again into x plus 3 and x minus 3, and then x plus 2. Okay, so I'm going to rewrite that over here. That's our factored version of the numerator. Now the denominator, we can take an x out, leaving us with x squared minus x minus 6. And then we want to think multiplies to -6 and adds to -1. So the two things that would do that would be a minus 3 and a plus 2. So that would become our denominator. Well, the x minus 3's divide out. Now when you divide out, really there's 1's there. Okay, but if you're multiplying by 1, it doesn't show up. Really, we would need to know that if everything divided out. And the x plus 2's divide out, so you're left with the x plus 3 over x. So that's how you get it mathematically, but probably the store way is the easiest way to do that. All right, June 2018, number 9. Okay, so same test we were just on, just a few problems over. What is the solution set of the equation? So there's a phrase there that should jump off the page at you and say, I know I'm going to get this question right. Solution set. Okay, if you see solution set, again, let's look over to the sideboard. Solution set, or find the value of any variable, x, t, theta, or any other variable. You're going to store the possible answers and see which ones work in the original problem. So, we're going to pause the video for like 3 minutes. You're going to start off, you're going to do 3 stored as x, because that's our first answer here. And type in the original problem. See if it comes back as true. True is all we want. Okay, undefined, non-real solution, false. We don't want any of those. So if it comes back as true, then we know that's an answer. Okay, and then you can eliminate any ones that don't have that answer and go from there. Okay, so we're going to pause for 3 minutes to allow you to do the stores for this to see which ones are the correct answers. All right, so do 3 stored as x. Type in the equation. Notice you get false. So because 3 was false, we know 1 is not the answer. We know 3 is not the answer. Well, now the ones remaining, we are guaranteed that 3 halves is a solution. So we just want to store -1 for x and test it out. -1 came back as true, so that tells us it must be choice 4. Now, if you want to be extra certain and you have plenty of time on the test to do that, you can store the 3 halves and just make sure that is as well. Okay, to do this mathematically, you would get your common denominator. So these would both be multiplied by x plus 3, and these ones by x. You can only get common denominators by multiplying, not by adding. So this would become 2x plus 6 minus 3x squared equals x squared. If we get everything on one side with a positive x squared, we'll get 4x squared when we add the 3x squared over, minus 2x minus 6. And if we divide everything by 2, we'll get 2x squared minus x minus 3. This is an example where you have to do a times c method. A times c gives us -6. So we want to multiply to this and add to the -1. So that would be -3 and 2. So this would become 2x squared minus 3x plus 2x minus 3. You can take an x out of this, leaving you with 2x minus 3. You would have 2x minus 3 here. We would put a 1 out front. So this would give us x plus 1 and 2x minus 3 equals 0. So notice this is a lot more work than just doing a store. Set them each equal to 0. This would give us x equals -1. Here we'd add the 3 over and get 2x equals 3, and divide by 2 to get x equals 3 halves. But if we did this algebraically, we'd still have to store them and check them to see if they worked out. So that's why in a multiple choice, it makes no sense to do it algebraically. But we want to be somewhat comfortable doing it algebraically, just in case it's a free response. All right, next up, August 2018, number 29. I'll give you about 30 seconds to flip there. This was a 2-point part 2 question on this test, so August 2018, number 29. So we can't store this. This is a free response, so we got to get our common denominator. So notice we have an x plus 3. Now I want us to think of 6 as 2 times 3. And I want us to think of it that way because we already have 2's in the denominator. So every denominator is going to need a 2, a 3, and an x plus 3. So this first denominator here, it's still going to need the 2 and the 3. This one is going to need the 3 and the x plus 3. This one just needs the x plus 3. And this one needs the 3 and the x plus 3. And I got to multiply each of those on top too. And this one needed 3 and x plus 3. Okay, so it's kind of messy. There's a lot going on there. But once you have the common denominator in your equation, you can just write the numerators. So we have negative 3 times 2 times 3. We have plus 1 times 3 times x plus 3 equals x times x plus 3 minus 1 times 3 times x plus 3. Negative 3 times 2 is negative 6, times 3 is negative 18. This is really a 3 just that we're going to distribute through, so we get plus 3x plus 9. The x distributes through to give us x squared plus 3x. And this is really a minus 3 we're going to distribute through, so we get minus 3x minus 9. If we combine some like terms, this is 3x minus 9 equals x squared minus 9. We'll add the 9 over and subtract the 3x over because we want to be with the positive x squared. Well, notice the negative 9 and 9 add to 0, and we just get x squared minus 3x. Well, this should actually be easier to factor, but I find a lot of times people find it harder to factor. We want to recognize that there's no constant term, so we just want to see what can we take out of everything. Hopefully we recognize we can take an x out, leaving us with x minus 3, and then we just set each of those equal to 0. X equals 0 is already done, and we'll add the 3 over to give us x equals 3. But it's a fractional equation, so we have to check our answer. So I'm just so it's a little less messy up here for you to see, I'm gonna erase those things. Okay, we're gonna pause the video for 2 minutes, and we want you to check 0 and 3 in the original equation to see which ones work. All right, we should have got that both of those came back as true. So both answers are keepers. Okay, so fractional equations, log equations, and radical equations are the ones you have to check. All right, we're going to move on to transformations. So we want to look at June 2018, number 19. So we'll give you 30 seconds to flip to there in your booklets. June 2018, number 19. So we have a log base 2 of x. It's translated 1 unit to the right and 1 unit down. We want to know what the x-intercept is. So we're going to have log base 2. And on the inside, it's going to change if we're going right 1. If you go right 1, we're really subtracting on the inside. So that's going to be x minus 1. And if you go down 1, that's where you subtract 1 on the end. So we can just go over to a graphs page now in our calculator. We're going to type this in the graph and just see what does it look like the x-intercept is. So we'll go to the graphs page. Log is just to the left of the 1, but you got to hit the control button. So log base 2. In our parenthesis, we now have x minus 1. Make sure you move out of the parenthesis with the minus 1. And then we just want to see where it's crossing the x-axis, and it's crossing at 3, 0. So that would be our choice for this one. Okay, so you have to know your transformation rules in terms of your shifts, left, right, up, and down, and then you can just graph it from there. All right, we're going to go to August 2018, number 17. We'll give you 30 seconds to flip to that spot. Again, August 2018, number 17. All right, so we got two graphs here. New York State is the dots, the national amount is the stars, and they're showing gas prices over time. New York State's prices are modeled by G of X. So the dots are our G of X. We want to know which of these shows the national average. Well, if you look at each of our choices, these are all showing shifts. This would be a left shift, this would be a right shift, this would be up, and this would be down. And we just want to see from our dots, the New York State, in general, okay, so it's kind of rough, but we want to know in general what shift took place with the graph. Okay, and it's not going to match up perfectly, but we just want to know roughly in general what shift took place. And the best one that you could do to match up the graphs would be to shift the New York State one, the dots, downward. So choice 4 would be the best one there. All right, last one we're going to go to is August 2017, number 36. So we got to flip backwards some. And we'll give you 30 seconds to get there. So, using a microscope, a researcher observed and recorded the number of bacteria spores on a large sample of uniformly sized pieces of meat kept at room temperature. A summary of the data is shown in the table below. Using this data, write an exponential regression equation rounding all values to the nearest thousandth. All right, so to do a regression, we need to go to a list and spreadsheet page. So let's everyone go to our calculators, and whenever you're going to do a list and spreadsheet, go home and go 1 to open a brand new document, and you don't want to save. The reason we need to do this is so that we can reuse any variables. We had stored a lot of variables. We want to make sure we can reuse them. So we'll go to our list and spreadsheet page. In our chart, they just had X and Y, so I'm going to make those as my heading. Okay, and we're going to pause the video now for 2 minutes for you to put the data in, and then we will come back together to finish off the problem. Okay, when doing a regression, it's always good to just double check your values, make sure you typed them in correctly. Like notice it went 1, 2, 3, 4, 6. There was no 5 in our chart. Make sure you are in an empty box now. We're going to go to Menu. We're going to go to Statistics. We're going to go to Stat Calculations. And the regression that they wanted was an exponential regression. So exponential regression is down as letter A. So Menu, Statistics, Stat Calculations, and we want exponential regression. We're going to tell it what we called each thing. We called them X and Y. And go down and hit OK. And it gives us a bunch of stuff. Notice it tells us that it is in the form a times b raised to the x. Well, it's up to us to know that we have to put the y equal in that equation. So we're going to have y equals, we're going to have something times something, and it's going to be raised to the x. And we need to round to the nearest thousandth, which is 3 spots. Well, our a is 4.1679. The 9 bumps our 7 up to an 8, so we have 4.168. times, we need our b value now, 3.9806. The 6 bumps the 0 up to a 1, so 3.981. And we are raised to the x. Now the second part says the researcher knows that people are likely to suffer from foodborne illnesses if the number of spores exceeds 100. Using the exponential regression equation, determine the maximum amount of time to the nearest quarter hour that the meat can be kept at room temperature safely. So 100 was a number of spores. If we look back in our chart, spores was the y value. So we're going to put 100 in place of y. So we'll have 100 equals the 4.168 times 3.981 raised to the x. And we're going to go to a graphs page and we're going to graph both of those. So go Control Doc, go to a graphs page. We're going to graph 100. And then we'll also graph the 4.168 times 3.981 raised to the x. Now, we can't see anything here because we need to see up to at least 100. So I'm going to make mine like 120 here. And notice now we see where they're crossing. If you want to find something on a graph, you usually go to Analyze Graph. Menu, Analyze Graph. We want intersection. So choose either side of it. We get 2.3 and we get 100. Now notice, let's see where they wanted us to round to. They wanted to the nearest quarter hour. So quarter hour is like 0.25. So we had 2.3. So we got to think in quarter hours. So 2, 2.5, or sorry, 2, 2.25, 2.5, 2.75, 3. Which of those quarter hours is 2.3 closest to? Well, it's closest to 2.25. So our final answer here would be x equals 2.25 hours. And we can just draw a rough picture of our graph, 2.3 comma 100, to show that for some work. All right, that's it for today. So you remember to do your homework on a separate sheet of paper, unless it's one that's on a grid, and have a good rest of your day.